Okay, so 10.2, we're talking about matrix operations, and this lesson we kind of saved because it takes a little bit longer. It's not really difficult, I will say that. Matrices are just a special way to kind of organize data. So a lot of times when you talk about a matrix, you'll have rows and columns of things, and they represent something in a problem. Okay, and so we can use matrices to solve problems. And a lot of times they're word problems. We're not going to get to that a lot in this class, but in college algebra, they will move to that. So if you just kind of think about something that, if you think about a table, let's say that we're talking about a company that sells cars. Let's say that we have week 1, right, week 2, and week 3, and then on the top, maybe we say this is the amount of trucks. I'm just making a really brief example, cars, SUVs. So if we did 32, 47, 65, 22, 76, 22, 19, I'm just making up these numbers, 18, 37, this would be a matrix. And so if I talked about this number in specific, it would mean that on week 2, the company sold 76 cars. If I talked about this number, it would mean week 3, they sold 37 SUVs. So matrices are just a way to organize data and help us solve problems. Not anything scary. And you can work a lot of the problems on the graphing calculator, and I'm going to show you how to do some of that here in just a minute. But this first says both matrices are 2 by 2 and corresponding entries are equal. Okay, so if you compare, we've got a 1 here, we've got a 1 here. We've got a 2 and a 2 in the same place value. We've got a 3 and a 3 in the same place on both matrices. And we've got a 4 and a 4 in the same place. This matrices is called a 2 by 2. You always want to go down first, and the reason that this number right here is a 2 is because there are 1, 2 rows. And the reason that this number is 2 is there's 1, 2 columns. So always think about going down first when you're labeling these. And we're going to talk about that. We actually talked about that a little bit in the last section, but we'll go over it again. This says find X and Y. Remember, if matrices are equal, their corresponding entries are equal. And so you will need to set up equations involving any entries that contain variables. So these 6x and -9 are in the same place. So if I want to find x, I could say, well, 6x is equal to -9. 25 and 5y are in the same place on that matrix. So I could say, well, 25 is equal to 5y. We know how to solve these. On this one, we would divide by 6 to get rid of the 6. And so x would be equal to -9 over 6, which is -3 over 2, which could also be represented as -1.5, just depending on how they wanted the answer represented, a fraction or decimal. Okay, on this one, we would need to divide both sides by 5, and y would be equal to 5. Okay, so you're just going to set these things equal to whatever is in the exact same place to solve these. So on this one, we've got x minus 1. Well, it's in the same place as 0. So we could figure out what x is by setting x minus 1 equal to 0. We would add 1, and so x would be equal to 1. Okay, I see another variable, and it is y, and y plus 3 is supposed to be equal to -2 because they're in the same place on the matrix. So y plus 3 is equal to -2. We would subtract 3, and so y equals -2 minus 3, which is -5. There's not any other variables, and if you'll notice that we have a 4 here, a 4 here. They have to be the same because they are saying that they're equal to each other. We have a -7 and a -7 in the same spot. Okay, so that's how you would solve those. Adding matrices is very similar. You're gonna add the number that is in the same place on both matrices. So I'm going to write this out. I'm also going to show you how to do this on the graphing calculator. I'm not going to go back and forth for all of them because it would take forever, but I am going to show you how to do this on the graphing calculator. So if we look at this first example here, they said to add A and B together. I add A and B. So what we would do, and now in order to add them, they have to be the same size. This is a 2 by 2 because it's 2 rows and 2 columns. This one's also a 2 by 2. So we are able to add them when they are the same size. So we would say, take our first row, first column, we would add those numbers. -5 plus 6, that's what would go there. Then we would take we would go to the next thing, take our 0 and our -3, add those. Okay, we would keep moving. Go down here, we got a 4 and a 2. That would be in this position. And then lastly, we have a 1/2 and a 3, and we would want to put those two together. So our final answer would be -5 plus 6 would give us 1. Zero plus -3 would give us -3. 4 and 2 is 6. 1/2 plus 3 is 3 and 1/2. Okay, so that would be the answer to this matrix. And I'll go and show you on the graphing calculator in just a minute. So A and B have the same order so that we can add them. These are both, if you go down first, remember you go down first, and you get 3. And when you go over, it's 2 columns. So 3 rows, 2 columns. So they are the same. So we should be able to add them. So we're going to do 1 plus -1, 3 plus -2, -1 plus 1, 5 plus -2, 6 plus -3, 0 plus 1, and then we're just going to figure this out. 1 and -1 is 0. 3 and -2 gives us 1. -1 and 1, 0. 5 and -2 gives us 3. 6 and -3 gives us 3. And 0 and 1 gives us 1. So that would be our final answer. Now I'm going to go straight to the graphing calculator for this one because I think you have the idea. So in the graphing calculator, we're going to call this matrix A. We're going to call this one matrix B. So I'm going to go switch over to my graphing calculator and we're going to type this stuff in. Okay, so here is my graphing calculator. I'm going to, let me clear this stuff out real quick. So the first matrix that we need to type in is a 2 by 2 matrix. So I'm going to go second, x to the -1, because if you'll look closely, we have the word matrix written above that. Now we want to edit the matrices so that we can put in there what actually is in that matrix. Okay, so when we go here and edit, sorry, I'm going to use my arrows, go over and edit. I'm going to hit enter because you can see that 1 is highlighted. And so I want to hit enter here. And then we want to hit 2. It's a 2 by 2. And it looks to me, so we want to type the numbers that we have, and we said matrix A was going to be a -6, 7. So I'm just typing over what I have. The bottom row was 2 and 1/2. And you can use your alpha y equals if you want to leave it as a fraction and type it in that way. That's fine. Okay. Next, I want to go in and put matrix B in. So I'm going to do second, x to the -1 again, matrix, hit enter. And here's where a lot of people go wrong, because they try to go, they know they need to go over to edit, okay? And then they want to hit enter again. And when they do that, they're typing over what they put in matrix A again. And we don't need that. We need to edit matrix B. So we're going to go over to edit, and then we need to go down to matrix B and hit enter, because we want to type something new in for this one. This one is also a 2 by 2, and so you're just going to type over that. And this is going to be, so this one was 2, -4, -8, and the last one was -4. So that's what goes in those spots: 2, -4, -8, -4. Okay, so once we get the matrix A typed in and matrix B typed in, we're ready to add them on our calculator. So I'm going to hit second mode to kind of get out of that. And I want to hit second matrix again. This time I don't want to edit matrix A, I just want to select it. So I'm just going to hit enter. And I want to add it to matrix B. So I hit the add sign, the plus sign, and then hit second x -1 again, go down to B, hit enter again, and there's the answer: -4, 3, -7, and -7/2. Okay, so we've worked this one on the calculator. I will work some other ones on the calculator, try to work one of each just so we can practice putting them in the calculator. But let me get a pencil so I can jot that down and write it on your paper real quick. My memory is not that good, unfortunately, when I go back and forth. Okay. So come here, and we know that, so we did this one in the calculator, and we got the answer was -4, 3, -6, and -7/2. Okay, same thing, we could do this one on the calculator as well. I'm going to do it by hand. We know that we need to add the same in the same position. So 1 + 2, 4 and 4, -2 and -4, 6 and 2, 7 and -5, 0 and -3. That's going to get us 3, 8, -6, 8, 2, -3. Okay, in my opinion, when you're just adding them or subtracting them, the calculator is a good tool, but you can almost just do it as fast just by doing it. But I will say this, the calculator is a good way to check your work and make sure that what you're getting is agreeing with what you get in the calculator. You can catch mistakes, either mistakes you made on the calculator, because it is possible to type something in wrong, but you can also catch mistakes that you're making if you're just subtracting or adding wrong, okay? Now, let's look at what happens when we subtract. So, very same principle here. When we're subtracting, if we're doing matrices C minus D, you're going to do 1 minus 1. And move to the second row, first row, second column on both of them and do 2 minus, now watch out, we're subtracting these two. So 2 minus, and then this is going to be a -1. Okay, on the bottom, we've got -2 minus 1, 0 minus 3, -3 minus 2, and -1 minus 3. So subtraction is always a place where people make mistakes because they're like, well, there's already a minus here on this -1, and so they don't want to do minus a minus. We know that minus a minus is positive. So 1 minus 1 is 0. This ends up being 2 plus 1 because a negative is a positive, which is going to give us 3. -2 minus 1 is -3. 0 minus 3 is -3. -3 minus 2, -5. -1 minus 3, -4. Okay. So they've got us subtracting C and D again. If you'll look at this matrix, if you go down and over, this matrix is a 2 by 2. If you go down, we've got a 2. But if we go over, we only have a 1 here. So it says C is a 2 by 2 matrix and D is a 2 by 1 matrix. Since the order of C is not equal to the order of D, we cannot subtract. Okay, they have to be equal to each other for us to be able to move on and subtract those things. Okay, so we will do one on the calculator. So let's go ahead and just type this one right here in on our calculator. So I'm going to go back to the calculator screen. Pardon me. So I'm going to clear this out. So I'm going to go second matrix. Now, the adding and subtracting, I will say this, the adding and subtracting are very easy to do by hand. When you start having to multiply them, they get a little bit more complicated, which is one of the last things we're going to do in this lesson. So I definitely would practice doing this on the graphing calculator so that you're ready for when you have to multiply, because you're going to want to use the calculator when you multiply. The two matrices, so I'm going to go over to edit. The two matrices that we're supposed to put in this time are both 3 by 2s. So I'm going to go through our first matrices, and these are labeled C and D. It doesn't matter what you label them as when you type them in the calculator, as long as you pick two different ones and you know you're subtracting one from the other. So you can just go in and type in over what you have. Make sure you use the negative button for negative numbers. Don't use so in other words, use this negative button down here by 0. If it says -3, don't use the -3 button, because it's going to make you have errors when you do that. So -4 and -2 are going to be the numbers that go in matrix. And for us, on our paper, it says matrix C. It's fine if you call it matrix A on the calculator. Okay, the next thing I need to do is I need to type in matrix D. So I'm going to go second matrix, and I'm going to go over to edit. Now, we said that this is where people make a lot of mistakes, because they just end up going over to edit and they hit enter, and they end up typing over their matrix A that they just typed in. Make sure you scroll down to get B. And this is also a 3 by 2. Sorry, what am I doing? Should have looked up. I accidentally typed in a 3 by 1. And sorry about that. So -1. And then I kept going. So this needs to be a -1. Let me just start over. Sorry about that. We've got 1. -1. Third time's a charm. I accidentally was typing the problem above. -1 that we already worked. -3, 4 and 7, and 0 and 3. And now I need to go back and check that I typed the right thing in for matrix A. I think I did, but I need to make sure. I'm going to go back and look at that one. So I'm going to second matrix, and I'm going to go over to edit, and I'm just going to make sure that I type matrix A incorrectly according to the problem we have, and I did. Okay, so second matrix, we want to do A minus B, so second matrix. We'll scroll down to B. We're not editing it. We've already typed it in, and then hit enter. And here is our answer. When we subtract these, so 2, 7, -7, -7, -4, and -5. So that is what we got when we subtracted these two. 2, 7, -7, -7, -4, -5. Okay, so that's the answer to this one. This, if we go down and over, this is a 2 by 1. Down, over, this is a 2 by 2. We not do circle, can't subtract. They are not the same size matrices. Okay. So this one says find -A for A is this matrix. Well, that's real easy. If we're if it's just telling us this negative, means opposite. So it's just saying take all of the matrix, and if it was +1, make it -1. 0 doesn't have an opposite. If it's 2, make it -2. 3 would be -3. -1 would become +1, and 5 would become -5. So this would be our answer. Well, what happens when we take A and we add it to its opposite? Well, we're going to get a 0 matrix because everything is going to come out to be 0. 1 plus -1, 0. 0 and 0, 0. 2 and -2, 0. So there is something called a 0 matrix, and it's whenever you have one matrices and you add it to another matrix that is exactly opposite of it. Okay, when we're multiplying, and we call this a scalar product, by a number out front, all we're having to do is take it. So if we're doing 3 times A, we're going to take everything inside of this matrix. So we've got -3, and they want us to multiply it by 3. So it would be 3 times -3. This place has a 0, so it would be 3 times 0. We're taking everything and multiplying it by 3. 3 times 4, and then the last one would be 3 times 5. So that our final answer would be 3 times -3, that's -9. 3 times 0, 0. 3 times 4, 12. 3 times 5, 15. Okay. So I'm going to use this same A. So if we're taking A and multiplying it by -1, -1 times A. Well, -1 should just be the opposite of what we had. So -1 times -3, -1 times 0. I'm using this matrix right here. -1 times 4 and -1 times 5. We would end up with 3, -1, -4, -5 is our answer. It would be the exact opposite of this. Okay, so can we do these problems in the calculator? Can we do these matrix, like just multiplication of matrices in the calculator? Absolutely, you can do the multiplication of matrices in the calculator. So I'm going to show you how to do that now, because we can actually use it for both of these problems. So we are going to go to our calculator, and I'm going to clear this out. Second matrix, this time I only have a matrix A that I'm having to worry about. So I'm going to edit that. Our matrix is a 2 by 2, 2 rows, 2 columns, and we've got -4, I don't know what's going on with that, sorry. Okay, -4, 1, 0, 7. Okay, and then we want to do 3 times that. So I've already typed it in. So there's my matrix. It wants me to multiply 3 times matrix A. So I'm going to do second matrix. I'm going to hit enter because I've already typed in A, and it tells me the answer is -12, 3, 0, 21. So -12, 3, 0, and 21 is what we get. Let me do that. So we multiplied this out. -12, 3, 0, and 21, not 27. Okay, we've already typed this matrix in. They want us to do -2 times A. So I'm going to go back to my calculator. We could do this by hand. There's no problem with that. I just want to make sure I give you plenty of examples on your calculator. You can go up here and grab what you have and hit enter, and then go back and type over through an insert because it's the same matrix. So -2, and delete out that 3 right there and hit enter. Or you could just type -2 and then go back to your matrix and get it that way too. But it's taken -2 and multiplied it times everything. So this is what we would get when we do that. Okay, so really just taking -2 and multiplying it by -4, that's going to be 8. -2 times 1, which is, this is the same thing the calculator gave us. -2 times 0 is 0, and -2 times 7 is -14. Once again, if this is all I had to do, it might just be easier to do it by hand. You don't have to do it on the calculator, but the calculator is a good tool to check your answers. And I will say in just a minute, when the problems are starting to get a little bit more complicated, you might want to use your calculator to get the answers, because it will help. It will help you quite a bit. Okay, and here's an example of something that when we start trying to do multiply 2 by A, multiply 3 by A, then add them together. Okay, so this would be a good one to type in the calculator. If we let this be matrix A and this be matrix B. Okay, so I'm going to go to my calculator and do this real quick. You can do it by hand. If you did it by hand, you would just take everything in matrix A and multiply it by 2, everything in matrix B and multiply it by 3, and then add them together. Okay. And I will say, when you're adding, you probably will make less mistakes than when you're subtracting these by hand. But if you're subtracting, you probably for sure want to type it in your calculator and make sure that you're doing this correct. So these are 3 by 2s. One, 4, -2, 6, 7, 0. So there's my matrix A. Get out of that. If you're following along, let me give you a minute to type that in really quickly. Okay, I'm going to go to second matrix. I'm going to go over to edit and down to B because I have another matrix that I want to type in for B. It is also a 3 by 2. And so 2, 4, negative 4, 2, negative 5, negative 3. Okay, and I'm going to get out of that real quick. So I've typed in the second matrix. I have matrix A and matrix B. While you're typing that in, the whole goal of this problem was to take and multiply matrix A by 2 and add it to matrix B that has been multiplied by 3. So let's get out of this. Okay, I don't know why, sorry. So we want to do 2 times matrix A. So to get the matrix A to come up, we'll hit second matrix and hit enter, plus 3 times matrix B. So second matrix, and we'll want to scroll down to highlight B, hit enter again, and it gives me the answer. So we've got 8, 20, negative 16, 18, negative 1, and negative 9. So we get these answers by taking matrix A and multiplying by 2, and matrix B and multiplying it by 3, and then adding them together. Okay, so you can use your graphing calculator to do that. And I do think that in this case, it probably does save you a little bit time. I'm just going to put, we work this on the calculator, but we get 8, 20, negative 16, 18, negative 1, and negative 9. Okay, down here there are some principles of what's possible to do with matrix, kind of the rules of matrices. You've got the commutative property and associative property, distributive property, additive identity property, and additive inverse property. I don't think you're going to have to really know the names of those, but it is nice to know that those rules exist and that you can use them. Okay, so it says for A is equal to this, and B is equal to this matrix, and C is equal to this, find each of the following. So they're wanting us to do A times B, B times A, and they're also wanting us to do B times C, A times C. And so I am going to go straight to the graphing calculator, and let's go ahead and get these matrices typed in so that we can fly through this real quick. Okay, I'm going to show you how to do multiply them longhand in just a minute, but I do want to show you how you can kind of use the calculator to tell you when, a couple of things. It'll tell you when it's not possible, and I want you to be able to see those things. So I'm going to go to the calculator. Clear this out. I do have 3 matrix to type in. So second matrix, we're going to go over and edit, and we're going to edit matrix A first. Matrix A has 2 rows and 3 columns. Okay, make sure you have enough time to type it in. It was 3, 1, negative 1, 2, 0, and 3. Now we want to put in, if you need to pause this on the video, that's fine. Second matrix, this is tricky. Remember, we go over to edit, then we're going to go down to B. And matrix B is 3 rows, 2 columns. So this was already correct. We have 1, 6, 3, -5, and -2, and 4. Okay. So there's that one. The last one is matrix C. So second matrix, go over to edit, but this time we do have something. We're going to go down to matrix C, and matrix C is a 2 by 2. And if you'll notice, every one of these were a different size, so we couldn't add them or subtract them because they don't match. We're going to attempt to multiply them, and you can multiply them when they are different sizes, but they do have to follow a certain rule. So here's matrix C. It's a 2 by 2. It was 4, -6, 1, and 2. Okay. So the very first one that it wanted us, while we're on this screen, the very first one it wanted us to multiply is A times B. So I'm going to get out of this, and I'm going to go second matrix, and I'm going to hit enter because it wants me to multiply A times B. So second matrix, we want to go down to B to get the B to show up. So enter, and that one is actually possible. It gives us an answer. It says 8, 9, -4, and 24. Okay, and I'm going to show you how to do that longhand on this one, but I'm not going to do every one of them that way because I think you will not want to be doing everyone that way. But here's what we know about this one. Okay, first thing is we know that A has, okay, it has 3 columns and 2 rows. Therefore, so 3 columns, 2 rows. This is a 2 by 3 though, matrix. Therefore, we can perform this multiplication or we cannot perform this multiplication. Well, it depends on what B has. B has, so matrix A is a 2 by 3. Matrix B, and I'm going to write this backwards and I'll show you why. Matrix B, you have 3 rows and 2 columns. Okay. If this number, and it has to be in this order, right? We're doing A times B. If this number matches this number, okay, the ones that are right beside each other, if they match, then you can perform the multiplication. The 2 numbers have to match and you can perform the multiplication. The answer that we got when we did it on the calculator was 8, 9, -4, and 24. Okay, I'm going to show you how to do this the long way. So they want us to take matrix A. I'm not going to, like I said, I'm not going to bore you with this on every one, but I do think it's important that you know where this stuff comes up with. And they want us to multiply it by matrix B. So I'm just copying down the numbers at the top. Okay, the first thing that you do when you're trying to get the answer to this matrix is you take the first row and the first column. So the first row would be this, and the first column would be this. Now hang with me because this is kind of complicated. So you do 3 times 1 plus 1 times 3. So I'm just going down. This -1 would go at the bottom. So plus -1 times -2. And you would find the answer to that. And when you do, you're going to get 8. Okay, I'm going to scoot this over because we don't have enough room. Okay, next, this would be the first row and the second column. So still first row here, but now we're going to do the second column. So we would do 3 times 6. Okay, 3 times 6 plus 1 times -5 plus -1 times 4. I still didn't have enough room. Okay, if you do all of that, you're going to get 9. This bottom here would be second row and the first column. So the second row and the first column. So we would do 2 times 1 plus 0 times 3 plus 3 times -2. You can see now why you want to be able to type these in the calculator, because it makes your life so much easier. And if we did all of that calculation, we would get -4, which is this number, right? And the very last one would be second row, second column. So the second row and the second column, you would do 2 times 6 plus 0 times -5 plus 3 times 4. And if you did all that, you would get your 24. That is right there. So we definitely want to be able to use the calculator if we can on these. So can we do B times A? Well, B has 3 columns. B has 2 columns and A has 1, 2. Sorry, my brain went somewhere else. B has 3 columns I'm just going to write this here to help us. Maybe it'd help me more. Columns, 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 columns. Okay, so B has 2 columns, but it has 3 columns. Autumn, I'm so sorry, my brain's not working right now. B definitely has 2 columns. A has 2 rows. So let's go back up here. They said A has 3 columns and B has 2 rows. So when you look at this one, A is a 2 by 3, just like we said before, and B is a 3 by 2. They're not wanting us to do times B, they want to do times A. This worksheet, when we change it, we've got a 3 by 2, and we've got a 2 by 3. And so, again, these match. So because they match, we should be able to perform this calculation. So let's go and check. We can do B, the stuff in the calculator. Let's see if we can. We're going to do B times A. We're not changing our matrices. So this is just going to be a matter of going second matrix. We're going to go down to B this time. And then we're going to do second matrix. And we're going to do A. Okay, and now we've got this. It's definitely possible. It's a really big matrix, but notice that we were able to perform it because we had those things that matched up. I'm not going to do this one by hand. Jot this down. But when we go back to the page we're on, you can perform it. And the answer was 15, 1, 17, -1, 3, negative 18, 2, negative 2, 14. Okay, and so it's interesting because this is a 3 by 3, right? And you can get that by looking at this is a 3 and this is a 3. So you look at, see if the middles are the same. That will you do this. The answer is going to be the back 2. So on this one, we have a 2 and a 2. So 2 times 2 would give us, it would give us a 2 by 2 matrix for our answer, which is what we got. Okay, let's look at this one now. B has 3 rows and columns. So B has 2 columns. C has how many rows? C has 2 rows and 2 columns. When we look at B, we want B in the front, we want C in the back. We know C is a 2 by 2 and B was a 3 by 2. Okay, these numbers have to be the same in order for us to be able to do this. The answer that we get should be a 3 by 2 though, because that's the first and the last. So let's see if that's what we get. Again, we've already typed this in the calculator, so we should be able to get the answer really quickly. So it wants us to do B times C. Okay, and we are getting a 3 by 2 that ends up being 10, 6, 7, negative 28, negative 4, and 20. Okay. Okay, what about A by C? It says A has how many columns? A has 3 columns. C has 2 rows, therefore, okay, I always like to write it like this. I know that C is a 2 by 2 and A is a 2 by 3. These are different. If we write them in order, A times C. So we're not supposed to be able to do this. I'm going to go really quickly and just show you what that looks like in the calculator screen, because it's going to tell you, and that helps kind of. So if we do A times C, we're going to hit second matrix. We want A, and then second matrix we want C. Okay, and see it says dimension mismatch, and you can't do it. So you're going to know if you try to do it on the calculator, when you don't really have to memorize the rule, because if you try to do it and it doesn't work, you're going to know, okay, it's a dimension mismatch. Okay. This problem is essentially the same, so I am not going to waste your time with that. But that is what you need to know for 10.2, and that really wraps up this section. So the next thing after 10.2, we'll have the last test. I will try my hardest to get that recording of a study guide for the last test up before Thanksgiving break, just in case somebody wants to take it over Thanksgiving break. And after we come back, we're really going to be just studying for our final and taking our final, and we'll be done.